Everything that you need to know about integration by substitution will be in this video, so stick around. I'm just going to run through what it is, and then I'm going to give you some examples so you really gain an understanding of what integration by substitution is. So as a straightforward definition, you just simplify a function you want to integrate through substituting one value for another value. So let's try prove that the indefinite integral formula for tan of x is just the ln of sec x plus c. So the first thing that you want to do to prove this formula is to transform tan of x into sin x over cos x. Then you want to do a change of variable table on the side. Always do this for all integration by substitution types of questions. So the one that you want to pick is the one where when you differentiate it, it'll give the value of another value in the function. Why? Because it will cancel out when you replace dx with this formula. You need to get everything in terms of u, which is why you need du in this equation. So this is why you choose u as cos x, because you differentiate it, you get minus sin x, and so your dx is just minus du over sin x. And you put this in and it cancels out nicely and everything is in terms of du. So integrating this will give you minus ln of u plus c. Do not forget that plus c, and we carry that minus over to give ln 1 on u. And then you replace u with your original change of variable as cos x, and 1 over cos x is just sec x. So let's do an example with a definite integral. It's a little bit different. So here's the integral that you need to evaluate. And the first thing you want to do is a change of variable table on the side. And so as you can see, if you differentiate x squared, you'll get 2x. So your u is your x squared. And don't forget to rearrange to get your dx. So as you can see, the 2x will cancel out. And it'll give you this formula, cos of u du. So you evaluate it. The integral of cos of u is just sine of u, because if you differentiate sine u, you'll just get cos u. And I actually got this one wrong. So what do you think? What do you think went wrong here? Have a think. What step did I miss with a definite integral? Because the last one didn't have limits. This one does have limits. So I forgot to do a change of limits. So change of limits is pretty straightforward. You just plug in your lower limit into your formula. So when x equals 0, you will also equal 0. And when x is the root of pi, u will actually just be pi. So what I should have evaluated is sine u from 0 to pi, and that would have just been 0. So let's do one more example. So let's try evaluate this integral. Have a think of how you would approach this question and what would be your change of variable, what you would choose as u, and how you would go about changing the limits. So the change of variable would be u is equal to x squared plus 2x plus 5, because when you differentiate that you get 2x plus 2, which is just the top value. So when you rearrange it, the values will cancel out when you substitute dx into this equation. And of course do the change of limits as well while you're doing your tables on the side. So when x equals 0, u will equal to 5, so that would be your new lower limit, and when x equals 1, u will be 8, and that would be your new upper limit. So putting these in, you'll just get 1 over u, which is just ln u from 8 to 5, ln 8 minus ln 5, and remembering your log rules, your log laws, that is just in fact 8 over 5. So the key points to remember is indefinite integrals require the integration constant after evaluation. Always write a change of variables table on the side, and always write a change of limit table on the side if you're evaluating definite integrals. And always look for a differentiated version of the same function within the question. The next video is going to have a look at how to integrate by trigonomic substitution.